All right. So this is the answers to the quiz that was taken yesterday. Looking at number 1, the first thing that you need to do is find what TE stands for. Go to periodic table. Look for TE, TI. TI is found right here. If you notice, it is found in the section that needs a Roman numeral. TI stands for titanium. SE, go to the periodic table, find what it stands for, and it stands for selenium. Since it's the second or last element listed, it is selenide. To figure out what Roman numeral goes here, you have to look at the charge for selenide. Go back to the periodic table, find it on the periodic table. It is right here. It is found in the column that has a -2 charge. So selenide has a -2 charge. To balance that out, titanium has to have a +2 charge. Therefore, that is the Roman numeral that goes in the parentheses. It was a common mistake on the quiz that most people were looking at the subscript to decide how many or what Roman numeral goes in the parentheses. That is not the case. Moving on to number 2. Number 2 starts off with CU. We go to the periodic table and find CU. We will find that it is located right here, which again, it's found in the middle section. It stands for copper, meaning it needs a Roman numeral. To decide what the charge needs to be, I need to look at the second element so that I can balance the charges. O stands for oxygen. When it is listed last, it is oxide. Going back to the periodic table to look at the charge for oxygen to decide what my Roman numeral is, it's found in the group that has a -2 charge. So if this particular compound, looking at my formula, it is Cu2, meaning I have 2 atoms of copper and 1 atom of oxygen. If that 1 atom of oxygen is -2, that means the total for copper has to be +2, meaning each of them would be +1. So this +1 is what goes in the Roman numeral. Again, the common mistake was looking at this number and putting that as the Roman numeral. That is not how you do it. Moving on to number 3. Number 3, V, we go to the periodic table to find V. V is also found in the middle section, stands for vanadium, meaning, again, I need a Roman numeral. To decide what Roman numeral I need, I have to look at my second element that's listed, it's P, which stands for phosphorus. When phosphorus is listed last, it is phosphide. To figure out the charge, I need to go to the periodic table, figure out the charge of phosphorus. Phosphorus is located right here. It is found in the -3 group. So if I have 3 V's and 5 phosphoruses, each of the phosphorus being -3, my total negative charge is -15, meaning my total positive charge has to be +15. So if I have 3 vanadiums, each of their charges is +5. So +5 goes in as a Roman numeral. Moving on to number 4. Number 4, the symbol CO. Go to your periodic table, find CO. CO is located again in the middle section. It stands for cobalt, meaning again I need a Roman numeral. I need to decide by my second element or compound what Roman numeral I need. Okay, here's a parenthesis with a compound inside it, meaning it's on my list. So I go to my list, ClO3, locate it, It is right here. It has a -1 charge. So it stands for chlorate. If chlorate has a -1 charge, I have 3 of them. The total charge is -3, meaning the total charge for my cobalt has to be +3. I only have 1 cobalt, so that 1 cobalt gets the +3 charge. Number 5. Number 5 on, we start with Pb. Go to the periodic table. Pb is found right here. It is found in the plus-minus category. So with it being +-4, it is the first element that's listed. So it is going to be a +4 charge. Lead. Look up SO4 on my list. SO4 is right here. Do not confuse it with the one that's below it. That is SO3. So sulfate is SO4. Lead sulfate. Okay, so moving on. Now we are going to be writing the formulas. Writing the formulas of these compounds, we need to balance the equations. Starting off with number 6. Number 6 has zinc. I go to my periodic table to find the symbol for zinc. Zinc is right here. Okay? Zn. If it's not given a Roman numeral, you have to assume that it's 1. Again, zinc is a transition metal. Since there is no Roman numeral, we can assume that it's 1. Zn, the Roman numeral tells us the charge has a +1 charge. I am adding that to bicarbonate. Bicarbonate I do not find on the periodic table, so I need to go to my list and see if I find it there. There it is, and it has a -1 charge. HCO3. With a -1 charge. You notice my charges already balance each other out, meaning I only need 1 of each. Since I only need 1 of the bicarbonate, I do not need parentheses. Moving on. Cobalt 3-phosphate. Symbol for cobalt is CO. The Roman numeral tells me the charge is +3. I'm adding that to phosphate. I do not find phosphate on the periodic table, therefore I need to go to my list and find it. Phosphate is right here with a -3 charge, PO4. Since my charges are already balanced, I only need 1 of each. Moving on to number 8. Gallium selenide. I need to go to my periodic table and find gallium. Gallium is located right here in the +3 group, Ga. Selenide is selenium. Going to my periodic table, the symbol is Se and has a charge of -2. To balance them, I'm going to need multiples of each. Gallium is +2. Selenium, I'm going to need 3. So looking at this, I have a +3 charge. 2 atoms makes it a +6 total charge. With selenium, a -2. And 3 makes it a -6. So together they balance out, +6 -6. So you need to have gallium 2 atoms, selenium 3 atoms. Moving on to number 9. Strontium iodide. Strontium is found with the symbol of Sr. Go to my periodic table to figure out what the charge is. Strontium is found right here. +2 charge. Iodide is iodine. Go to my periodic table. I find iodine right here with a -1 charge. To balance them out, I need to have a +2 and a -2, which means I need another iodine. Number 10. Titanium has a symbol of Ti. Roman numeral +4 tells me the charge. I am adding that to fluorine. Symbol F. Charge on fluorine is -1. To balance it out, +4 and a -1, I need to get more fluorine to make it a -4. So I need a total of 4 -1 charges from the fluorine. All right, so all of these are ionic bonds. This seems to be what you're having the most trouble with. I will do a couple covalent bonds, starting with number 11. Covalent bonds use the number of atoms to show the prefixes. So if we look up Si, Si stands for silicone. There's only one of them, so I do not need to put the Roman numeral mono. I can, it would not be wrong. Looking at the next element is fluorine. I have 4 of them. Prefix for 4 is tetra. Since fluorine is listed last, I add the IDE to the end. Another example, I'm going to do number 15. I think you understand the most part of the covalent bonds. Number 15, I have 4 phosphorus. The element that is listed first, you do not change the ending. So tetraphosphorus, and then S stands for sulfur. I have 5 of them. Penta, you do change the ending of the second or last element so that it's IDE unless it's found on the list. Okay, moving on to the bottom section where we're actually writing the formulas for these. We do not need to do balance equations. These are much easier. You just need to have the right prefixes. The first element in boron, prefix di means 2. Second element, hydrogen, hexa means 6. Another example, I'll do number 19. Phosphorus is P, di 2. Pentaoxide, oxygen is O, penta is 5. I need to stop it, and for some reason the stop button is not up here.